We dedicate, what, roughly a third of our entire lives to sleep.
A huge chunk of time.
Yeah. And for centuries, we've kind of viewed this state as, necessary downtime, just a passive rest period.
Right, you're just recharging your batteries.
But the source material we've gathered this week tells a far more active, intensive, and frankly, a compulsory story.
It's a complete paradigm shift, really.
Sleep is not just about feeling rested. It's a non-negotiable physical maintenance cycle.
And the evidence suggests that the consequences of poor sleep are, they're literally etched into the physical structure of your brain.
Which is why we designed this deep dive. Our mission is to move past that simple question of, am I getting enough hours?
And instead ask, is my brain getting its necessary deep clean?
We've synthesized everything from MRI studies on brain volume to metabolic data.
Right, giving you the neuroscience blueprint for optimal brain longevity. We have the data on duration, quality, even how a short nap can help.
So, okay, let's unpack this. Let's start with maybe the most counterintuitive finding. Sleep isn't just mental. It's a physical cycle that literally changes the size of your brain.
That's exactly where the analysis begins. The research found that human brain volume isn't static across the day.
It's not.
No, it changes significantly within a single 24-hour cycle. And that change is specifically tied to overnight sleep.
Okay, I have to stop you there. When most people imagine spending 8 hours lying down, they'd think gravity would lead to, some fluid draining, maybe a slight decrease in volume.
That's the logical assumption, but the opposite is true. Brain volume is at its largest immediately after you wake up from overnight sleep.
Really? It's biggest in the morning?
Yes. Then it decreases for several hours, hitting its lowest point about 7 to 10 hours after you get up.
And then it starts to increase again.
Exactly, as you head back towards sleep. It is a daily expansion and contraction cycle.
So the brain is physically swelling just slightly every single night. That is an astonishing physical shift.
It is.
And here's the critical detail from the sources. This daily physical cycling, this diurnal volume change, it is only observed in people who report good sleep quality.
That is the pivotal finding.
So if your sleep is bad,
If your sleep quality is poor, that essential daily physical cycle of volume change is either absent or, severely weakened.
which points directly to the mechanism, right? The glymphatic system,
Yes, the activation of the glymphatic system.
the brain's maintenance crew. If you think of your nervous system like a city, this is the specialized storm drain system.
That's a great analogy. It's a fluid transport pathway. It uses cerebrospinal fluid, or CSF, to flow through the brain tissue and effectively flush out metabolic waste.
And this is so important because it's clearing out toxic proteins.
Exactly. Things like amyloid beta, which, when they accumulate, are strongly implicated in things like Alzheimer's and Parkinson's.
So to get that cleanup done, the brain has to literally open up space for the fluid to rush in.
Precisely. That explains the expansion.
And the studies back this up.
They do. Studies on mice show that during good quality sleep, the glymphatic system it opens for business. CSF influx goes up by over 90%.
90%? Wow.
And the space between the brain cells, the interstitial space, increases by over 60%. The brain is physically reconfiguring itself to maximize that cleaning flow.
So this turns sleep from passive rest into this really active, intense, fluid dynamic process.
It's not passive at all.
But that massive influx of fluid has to be driven by something more than just, lying down. What's powering the plumbing here?
It's all neurophysiologically driven. That enhanced flow isn't random at all. The key insight is that this cleaning is driven by these slow, large amplitude oscillations in blood vessels. It's a rhythmic movement called vasomotion.
Vasomotion. So it's like a pulsing rhythm.
Yes, think of it like rhythmic contractions that pump the fluid, increasing its velocity and helping to transport and disperse all those waste products out of the brain.
And this happens during a specific sleep phase.
It happens predominantly during non-REM and intermediate state sleep.
Which confirms that if your sleep isn't getting to that deep quality phase, your brain's plumbing is just running on low pressure.
That's the physical evidence right there. Poor quality sleep means your brain isn't getting its deep clean.
And here's where it gets really interesting, because this pulls us away from just clock watching, from how many hours did I get?
Right, and it pushes us into the much more complex question of how effective were those hours?
Let's talk about that relationship between duration and quality.
Yeah.
It's more nuanced than I thought.
We always hear about the magic number, and the data does suggest that for long-term brain microstructure, the optimal range is somewhere around 7 to 8 hours a night.
Okay, so there is a sweet spot.
There is. The relationship is often described as an inverse U shape.
What does that inverse U shape actually tell us?
It means the extremes are not great. Individuals who consistently slept less than 6 hours, or more than 8 hours, showed slightly lower scores on tests of general cognitive function.
So too little is bad and too much is also bad.
Both seem to carry a bit of a cognitive cost, yes.
But the sources suggest that even more crucial than just the number of hours is the quality of that sleep.
Precisely. Especially for long-term brain health. Things like regional brain volumes and microstructure seem to be more strongly related to daytime sleepiness and reported sleep problems than just duration alone.
So if you're consistently exhausted during the day, that's the bigger red flag.
That's a much bigger red flag.
And there's physical evidence of this, right? Poor sleep quality, measured by something like a PSQI score, negatively correlates with the microstructure of white matter.
It does. White matter tracts are the brain's high-speed communication highways.
The wiring.
The wiring, exactly. And if you look closely, poor sleep quality is associated with lower intracellular water diffusion in these tracts.
Lower water diffusion, what does that mean for me?
Think of it like a fiber optic cable. Healthy insulation lets the signal travel fast and clean. Lower diffusion is a marker of compromised integrity. The system is less robust, maybe slower.
And it affects specific parts of the brain.
Yes, the sources highlighted tracts like the cingulum and the superior longitudinal fasciculus. These are vital connections linking memory centers to your planning and executive function areas.
So the speed and efficiency of our own neural network is literally being degraded by bad sleep.
And it's not just the wiring. We also see abnormalities in crucial memory structures, the hippocampus, the thalamus.
Which creates a vicious cycle, I'd imagine.
It's a perfect setup for one. Poor sleep damages the very areas that regulate good sleep and memory, which leads to, well, worse sleep and worse memory.
And on top of the structural damage, there's this tight metabolic connection, the link to glucose.
This is one of the most remarkable findings. We know that even acute sleep restriction can cause insulin resistance.
Right, it increases diabetes risk.
Yes, but the mechanism is much more integrated with brain function. Think of memory consolidation during non-REM sleep. It's an intense computational process.
The brain is replaying and cementing memories.
And it does that with these high-frequency oscillations, hippocampal ripples, sleep spindles. And the sources show that when these memory processes are firing, they're accompanied by a transient decrease in your peripheral glucose concentrations.
So memory processing itself is drawing so much energy that you can actually measure a temporary dip in your body's blood sugar.
It's like watching the power meter surge when a big appliance kicks on. It shows how tightly coupled metabolism and memory processing are during sleep.
It's reciprocal too, isn't it?
Absolutely. One study even showed that fasting for 6 hours, which lowers baseline glucose, actually enhanced the density of these vital memory oscillations.
So your metabolic state can directly influence the brain's ability to form memories while you sleep.
It can modulate the very events that support memory.
Which brings us to the blueprint for better function. Given all this, what practical insights can we take away? Let's start with acute debt. The power of a nap.
The short nap is surprisingly effective, at least as a cognitive buffer. The sources looked at what happens after 30 hours of total sleep deprivation.
Which, predictably, is pretty bad.
It's bad. It causes severe cognitive impairment, especially increasing something called lapse times.
Those are those tiny moments where your attention just fails completely.
Exactly, even for a fraction of a second. A short nap, we're talking about 25 minutes, was shown to partially restore that function. It significantly reduced the lapses.
And it changes brain connectivity.
On a neurological level, yeah. It helped shift the brain's dynamic functional connectivity back toward the healthy, resting-like state that was dominant before the sleep deprivation.
So it's not a full system reset, but it is a measurable, powerful tool.
It is. It shows that even a small dose of quality sleep can interrupt that cognitive decline.
Beyond the nap, what about individual risk factors?
The sources highlighted that worse sleep quality was associated with higher depressive symptoms and lower education levels.
Reinforcing the sleep isn't isolated, it's connected to everything else.
Deeply connected. And linking back to the glymphatic system, poor sleep quality from something like sleep apnea also led to significantly lower glymphatic functioning.
So if you have apnea, you're not just short on oxygen, you're shutting down the cleaning system.
That's right. And the lifestyle factors were also really interesting, especially the data on coffee.
Right, because that showed some reverse causality.
Exactly. How does that work?
Well, we know coffee generally worsens sleep quality. But the study participants who reported good sleep quality were also the ones who reported higher coffee intake.
So the good sleepers are drinking more coffee, but the coffee isn't making them good sleepers. That seems backwards. It suggests that if you have naturally efficient restorative sleep, you just have less daytime fatigue.
It means you can tolerate a higher caffeine load without it messing up your sleep later.
That's it. The higher coffee intake is the result of being a good sleeper, not the cause. It's a great example of being careful with correlation.
So what does this all mean for us? Let's try and synthesize the core takeaways from this deep dive.
I think the most important synthesis is this. Sleep is a vital physical brain maintenance process. It is not passive.
It's driven by fluid dynamics and these neurophysiological pulses designed to clear out toxic waste.
And while that gold standard of 7 to 8 hours is still a good target,
We need to elevate the importance of quality.
correct, quality. So, the absence of sleep problems and daytime sleepiness, that is more strongly linked to long-term brain structure than duration alone.
And finally, that the metabolic machinery is deeply involved. Memory consolidation is an energy-intensive job.
It's all tied together. Diet, metabolism, and cognitive function during sleep. Ultimately, you have to think of sleep less as an inconvenience and more as a daily engineering requirement.
Which leads perfectly to the provocative thought we wanted to leave you with.
Let's do it.
We spent time detailing how the daily cycle of brain volume expansion and contraction, the physical evidence of the brain's deep cleaning system running at full tilt, is only apparent in people who are good sleepers.
Which suggests that if you're a poor sleeper, your brain might be stuck. It might be in a state of perpetually incomplete maintenance, unable to fully expand and contract the way a healthy brain does.
And for you, the learner, this raises a bigger question, a more personal one. If the fundamental physical flexibility of your brain, its ability to cycle fluid and volume properly, depends on good sleep,
How might the subtle, long-term disruption of that basic physical cycling show up in your waking life?
it means optimizing sleep isn't just about feeling better tomorrow. It's the essential requirement needed just to keep your brain physically pliable and structurally sound for the decades to come.
Under the canopy where shadows play, crickets sing secrets at the edge of day. A bird calls sharp like a question in the